Hello members of the alkaline, ionized, reduced electrolyzed hydrogen water community, and especially to the members of the Facebook Hydrogen Water Group. My name is Randy Sharp. Welcome to my presentation of the ionized water Teabag demo, microclustering or pH. For those of you who have never seen the Teabag demo, a Teabag is dipped into both 9.5 pH ionized water and tap water. And the 9.5 pH water will make tea while the tap water will not. The reason for this phenomenon is most often attributed to a property of ionized water called microclustering, which supposedly occurs during electrolysis, where water cluster size has been reduced from clusters of 15 to 20 molecules down to cluster sizes of 4 to 6 molecules. These smaller water clusters then are said to have a greater ability to penetrate both the Teabag as well as our cells. I decided to do 3 demonstrations which I believe will cast doubt upon this claim and at the same time offer some simpler, more reasonable explanations. After you see these videos, I hope you will agree. So why am I doing these demonstrations? My purpose in doing these videos is to persuade distributors who do the Teabag demo that the ionized water makes tea not because of microclustering, but mainly because of the higher pH. By more accurately explaining the mechanism responsible for this phenomenon, distributors are more likely to have credibility with their audiences. In the first demonstration, I will show how I can turn distilled water, which will not make tea on its own, into water which will make tea simply by raising its pH using a few drops of household ammonia. Let's get started. I've repositioned the camera so we can get a better view at the demonstration itself. I wanted to show you what I'll be using in the demonstration. This is distilled water that you can buy in any grocery store. And I'm going to use household ammonia. It's got a pH of about 12 or so, and it does a good job of raising the pH level of water, which is to say it raises the hydroxide level, the same thing that you do when you use electrolysis. I'm going to fill 4 cups, just about exactly 8 ounces. Three cups I'm going to use for the Teabag. This 4th cup, I'm going to put pH drops in it so that in addition to the meter, we can have a visual representation of what's going on. You can see that is slightly acidic. If I measure with the meter, dropping, it's going to eventually go below 7, I'm sure. Keep in mind this is not being done to laboratory standards. Please don't give me a hard time about the fact that I'm not using exact measurements. This will be close enough for my purposes. We're down below 7. It would probably go a little further looking at the color of the pH drops. That's close enough for our purposes. What I'm going to do is put 5 drops of ammonia in the center cup. I'll also do it on the far left cup. And that way you can see that whatever I'm doing to that cup, I'm also doing to the left cup, and have a visual indication there. You can see how what that ammonia did to the slightly acidic water. I can check the pH of that again. 9.3, 9.4. It would probably go above 9.5 if I kept it in long enough. I'm going to use Yamamoto green tea. just like we always use in the Teabag demo. A few dips in the distilled water with the slightly acidic pH, and I can see maybe a hint of color, not much. Pretty typical. If I move it over to the 9.5 pH distilled water that I raised with ammonia, you can see it does a real good job of making tea. Move it back to the slightly acidic distilled water, and once again, no tea. So as you can see, the distilled water, which could not be said to be microclustered, can make tea if you simply raise its pH. This ends the first demo. For more information on pH and microclustering, I recommend you visit Tyler LeBaron's new website at www.molecularhydrogeninstitute.com. Please find video number 2 to continue with the second demonstration. Thanks for watching.